This is the video for grade code used for starting the tray solution. Over here on the upper left is the routine that does the grade code search, but it only does it for the first 18 bits. If there are bits higher than the first 18, it's going to have a solution before this routine starts. That solution is going to be called the tray solution. That prior solution has a tray income. It has a tray binary number that is unique to that solution, and it knows how many parts are left. And that's in this value of tray left. It moves that in to test values at offset 2. So this is how it takes care of the bits above 18. Now, since this is all that it can do in one cycle of the program, over here is a routine that runs each cycle, and it decides what these test values are going to be. It sets the tray income, the tray binary, and the tray left for each cycle. The first thing it tells you is that it's working on the solution. It puts that on the screen. Then it tells you what index number it's at, and it tells you how many there's going to be. For instance, if you used all 26 bits, you're going to have 2 to the 8th power more cycles that it has to go around. This value loop count is going to be 256. So it's going to have to go around this routine only once each cycle, and in 256 cycles it may be near a minute to do that. Well, the very next thing it says, if the loop index is greater than the loop count, well, then it's done, and it can go to BJ down here, and then it just figures out what the quantities are for the best solution. However, if the loop index is not greater than the loop count, it goes on through this routine. First it says branch if equal loop index to 1. That means this is the first time it's going around. Well, the first time it goes around, it wants to leave all the values at tray, that's tray income, tray binary, and tray left to 0. So it just goes to BH and doesn't do anything. But the next time it goes around, it comes down here, and it sets control register N to 8. That's going to be used down here by this add list instruction, which needs to know how many values are in the list. There's 8. This particular problem here had only 8 things for parts, only 8 parts. So it only needs to have 8 in the tray left. Well, next it says set I equal to the loop index, subtract 1 from it. Well, the loop index has to start at the 2 before it comes down here. So it subtracts 1 from it, so then I becomes 1. Then it sets J to offset at 1. Down here is the offsets data. This is the offset list. And at 1 is this value of 20. Remember that this offset list tells it which bit to bring into the solution or take out of the solution. That's how the grade code search works. For instance, 20 here would say bring in the first one, 40 the second. I'm saying this because they're all 20 apart. That's why 1 is at 20 and the 2 is at 40. And then it says take the one at 20 out. That's what 1020 does. It takes that one back out. All right, so this is what it's up to with these offsets. So it comes down here and sets J to the value of one of these offsets. That's what item or bit is to be brought in or taken out of the solution. Well, let's say that the value of J is 20. Well, this next one here says the tray income is at offset grade data plus 360 plus that 20. That's at 380. Well, if we go to the file over here where the grade data exists, we'll see that 380 is the 19th one in the list. 20 times 19 is 380. And remember, that's the value we're getting here for this offset. It's going to go to the 19th one. That is, when it's at this 20, it's going to the 19th one. When it's at the 40 there, it's going to go to the 20th one. Well, if we go here to the gray data file, at this one, the income's going to be 20, and the unique binary number for it being in the solution is right here. Then after that is the parts that it needs. It needs 4 of this part, and I can see it doesn't need any of the other parts. Okay, so this here is your gray data, and it has data for every bit that there can be in the solution. Well, we'll come back over here, and here we see the income is at 360 plus the 20, so that's 380. The binary value, in this case, is at 381. And what we're going to change our tray left by is, in the first instance, when this is 20, is bringing the 19th one into the solution. Remember down here it says minus 4. It's going to take 4 of those parts away. So this is what it does on one cycle. As soon as it does that, then it goes here to the gray code search and does this search. And well, you know, when it does the search, it finds the best solution it can find in the search. Well, once the search is over, it adds 1 to the loop index, and then it exits. Therefore, the next cycle around, it's going to be pointing to another value in the offset list for the gray code, bringing 1 in or taking 1 out. Alright, so it's going to keep going around here until the loop index is greater than the loop count. Then it goes down here to BJ, and it says find the quantities for that solution using that binary number. Alright, this is the video for gray code used for starting the tray solution.